We will modify our algorithm slightly so that it applies to all numbers. I will subtract from 25, 7. 7 is greater than 5, so I have to borrow 1 from that 2. That becomes a 1, and this becomes 15. 7 from 15 is 8. 0 from 1 is 1. So 25 minus 7 is 18. I will do it using the 9's complement procedure now, with the modification that we need in order to make it valid for all numbers. 25 minus 7, to this difference I'm going to add a 0. I'm going to add plus 99. The reason for 2 9s is because there's 2 numbers in the minuend. Then I'm going to subtract 99. Okay? Adding a 0 to this difference will not change that difference. However, I don't want to subtract minus 99 because that's going to involve borrowings and carries. So I'm going to write minus 99 in this form, minus 100 plus 1. If I add plus 1 to minus 100, I get minus 99. So this is another way of writing minus 99. And then when I come to subtract this, it's a very easy subtraction, to subtract 1 from a number. From this 99, I'm going to subtract the subtrahend 07. In the 9's complement procedure, if the minuend numbers, there are 2 here, are greater than the subtrahend numbers, 1 here, I have to add a leading 0. We have to add as many leading zeros as we need in order to make the subtrahend and the minuend equal in number of digits. 7 from 9 is 2, 0 from 9 is 9. So this number 92 is precisely the 9's complement of that subtrahend 07. I'm going to add this minuend to it now, 25. 5 and 2 is 7. 9 and 2 is 11. So I have 117. When I'm doing subtraction by subtraction, the minuend number is reduced to a smaller number. When we do subtraction by addition, we are actually adding 92 to the minuend. So we're going to get a carry over into the 100th place, decimal place. It'll always be a 1, as we'll see. Then I'm going to subtract this minus 100. When I do that, I get 0 from 7 is 7, 0 from 1 is 1, minus 1, 1 minus 1 is 0, so I get 17. Then I'm going to add this 1, plus 1, and I get 18. I get the correct difference. So in the 9's complement procedure, I will take the 9's complement of 07, which is 92, put it over here, and I'm going to add it to the minuend. When I do that, I get the same number, 117, same as here. Now this step here where I subtract 100 and I get 17, and then I add a 1 and I get 18, is the same as taking this leftmost digit, which will always be a 1, and adding it to the rightmost digit, 7, and you will get 18. So I'm going to skip these 3 steps and state when you add the leftmost digit, which will always be a 1, to the rightmost digit, 7 in this case, you will get the correct difference, 18. And it's mathematically correct to do that. All I'm doing when I do that is skip these 3 steps. There's no need to do it. So this is the final form of subtraction by addition that's valid for all numbers. Okay. We'll try it now on several other problems to check its accuracy.